This is the solution to problem 44 on the Math Level 2 practice exam. You have a right circular cone, which is basically like ice cream cone. That is the radius is 5 meters, so that's the circle part, radius, typical radius, same as a circle. And the height is 3 meters. Okay. The radius of a cross-section parallel to the base. So a cross-section parallel to the base is simply another circle. We've got to figure out what is the volume of the section of the cone between the two bases. So what I want you to think about is not that section in between so much, but what about that cone, the bottom part? So that bottom part has some other, you can call it h small or something like that, and the radius on that smaller part is going to be 2. Okay, so now what is that height of this particular section? So we do like a cross-section parallel to the base, but what if you did the vertical slice? A vertical slice right through the center, like think about it cutting the diameter of that circle, then down to that point, is going to be, here you've got in the top you'll have a radius of 5, and then here you've got a radius of 2. Or in other words, you have a triangle with base 10, and this other part here is 4. Now you know that the overall height, h, is 3. It's not drawn to scale. Now what happens, what's this height? What's that height? Well, everything here is going to be similar, meaning the big triangle is similar in shape to this kind of smaller triangle, which means because of that similarity you can set up ratios. So in other words, that diameter to the height is proportional, meaning the two ratios are equal of the smaller triangle's diameter to its height. Call that HS to match that height small. Now cross multiplying and dividing, you have that small height is 3 times 4, which is 12, divided by 10, or 1.2. So the small triangle has radius 2 and the small height is 1.2. So overall, our plan at this point is to find the volume of the big right circular cone, the volume of the small right circular cone, and subtract the 2. That'll give us the volume of this middle space. So let's go ahead and do that. So get out a new piece of paper here. The large circular cone is going to be equal to, the volume that is equal to 1/3 of pi times the radius, which is 5, squared, times the height, which is 3. So 1/3 times 3, those will cancel each other out, and so it's 25 pi. The volume of the small right circular cone is going to be 1/3 of pi times the radius, which is 2, squared, times the smaller height, which is 1.2. So putting that here, just use a calculator to do this a little bit quicker. So we have 1.2 times 4, which is the 2 squared, and you get 4.8. Divide that by 3, you get 1.6. So this is 1.6 pi. Now we need to subtract the two. So subtract the small volume from the large one, and that'll give us the space in between. So 25 pi minus 1.6 pi. Those are obviously like terms, so we can combine the two. Now looking at the solutions, the answer, there is no decimal, so we may have to convert to some sort of fraction, improper fraction when this is done. 25 minus 1 takes you to the 24, minus the 0.6 is 23.4 pi. Alright, 23.4 is 23 and 4/10, which is 23 and 2/5 pi. So I'm going to multiply 23 times 5 and add 2. 23 times 5 and add 2 to convert to an improper fraction. That is 117 fifths pi. That's the volume in between, which is choice A.